So guys, welcome to our channel once again. In today's video, we have here these 8 practice questions to solve on energy changes. So guys, ensure to stay till the end of this video as this will be very helpful. So this video will be about spontaneity in reactions. So guys, if at any point you feel you want to answer any question here in this video, you can always pause the video and try out to see if you can get the answer to the question even before we provide the answer thereafter. So let's go ahead and start with the first question here. It says, what does a negative value of Gibbs free energy indicate for a reaction? A, the reaction is at equilibrium and has no net change. B, the reaction is spontaneous in the forward direction. C, the reaction is non-spontaneous and requires an input of energy to proceed. D, the reaction is at equilibrium, but it can be driven in either direction. So guys, the answer to this question here is option B. A negative value of the Gibbs free energy indicates that the reaction is spontaneous in the forward direction, and this means it will proceed without requiring an external input of energy. So guys, this option B here is the answer to this question. So let's look at the next question, and that's question number 2. We have an equation of a reaction here between nitrogen gas and oxygen gas to actually yield nitrogen monoxide, and the delta H here is 89 kilojoules per mole. And guys, if the entropy change for the reaction above at 25 degrees Celsius is 11.8 joules per mole, calculate the change in free energy. So we had to calculate the Gibbs free energy at 25 degrees Celsius for this question, and we have our options A to D here. And guys, in order for us to do this, we are simply going to go ahead and zoom into our workspace here. So remember, the first thing to do is to write down your equation here. So we have delta G as delta H minus T times delta S. So this meaning that the Gibbs free energy is going to be equal to the enthalpy change minus temperature in Kelvin times the entropy change. So guys, with this, from the question, we've already been given an enthalpy change of 89, and we also have a temperature set here at 25 degrees Celsius, and that will be 298 Kelvin. So 298 Kelvin. So this will be multiplied by the entropy change, and the entropy change of this system is 11.8. So guys, with this, let's recall that from the question we are given the enthalpy in kilojoules, and then we are given the entropy in joules. So we are simply going to divide these by 1000 in order to also get it in kilojoules, so that we can now subtract these when they are in the same unit. So with this said, delta G will be, all right, at this point we'll need our calculator. So let's go ahead and bring up our calculator here. So we're going to have 89 minus, so this is 298 times 11.8, so 298 times 11.8. all right, let's see what we have here. 3516.4. so if you divide this by 1000, you're going to just have 3.5 5164. So let's still confirm this is divided by 1000. So that's 8 here. So the next thing is, let's subtract this. So let's see what we'll have here. We're going to do our 89 minus 3.5164, and that's 85.48. So this is 85.48, in this case kilojoule, right? So that's the answer to this question, guys, and that's option B here. So let's go ahead and wipe this off, and then let's go ahead and consider the next question here, guys. The next question is question number 3. It says, when iron is exposed to mixture and it rusts, the value of delta G for the reaction is A, neutral, B, 0, C, negative, D, positive. So guys, the answer to this question is option C here, and that's negative. Now we know that the rusting of iron is actually a spontaneous reaction. So for any reaction that occurs spontaneously, that's the reaction occurs on its own without an external assistance in energy. So such a reaction, the delta G is usually negative. So the delta G is going to be negative. So iron rusting is an example of such situation. Iron rusting is a spontaneous situation, and therefore delta G will be negative. So that's it for that question. Let's consider the next question. Question number 4 here. It says, if a reaction is exothermic and there is a great disorder, it means that A, the reaction is static. B, there will be a large decrease in free energy. C, there will be a large increase in free energy. D, the reaction is in a state of equilibrium. So guys, for an exothermic reaction, we have to first of all note that an exothermic reaction is a reaction that releases heat, right? So this means that the energy of the product will be less than the energy of the reactant, and therefore this will translate to a decrease in the free energy. So guys, a great disorder means that there is a high entropy. Now, according to the second law of thermodynamics, for a spontaneous reaction, the total entropy of the universe must increase. So this means that an exothermic reaction with a great disorder is likely to be spontaneous. So this will lead to a large decrease in the free energy. So guys, that will be option B here, and that's the answer to this question. So let's consider the next question, guys. Question number 5. It says, okay, here we have an equation of a reaction, and the question here says the reaction above is carried out at 25 degrees Celsius if delta S is negative 106 joule per mole per Kelvin. The reaction will A, proceed spontaneously at low temperature, B, proceed spontaneously at the given temperature, C, proceed in the reverse direction at the given temperature, D, not proceed spontaneously at the given temperature. So guys, from the complete question we have, there is supposed to be a delta H which has a value of negative 72 kilojoules per mole. So now guys, if it's this way, we are going to have that delta G will be delta H minus T times delta S. So here we're going to have our delta G to be negative 72 minus the temperature, that's 25 degree plus 273, that's 298. Then this will be multiplied by delta S, which is negative 106. But guys, in this situation, this is in joule per mole, so we have to convert to kilojoules per mole by dividing this by 1000. So guys, with this, when we have 298 times 106, so this is going to be this, and when you divide by 1000, you're going to have 31.59. So delta G is going to be negative 72, then minus, remember this is going to be negative because of the negative value here, so negative 31.59. so guys, with this, delta G will be negative 72 plus 31.59. So guys, this will be negative 72, plus 31.59, and that will be a negative 40.41. So delta G will be a negative 40.41. So guys, this indicates that this reaction will be a spontaneous reaction in the forward direction. So it means this reaction will proceed spontaneously at the given temperature. So guys, that will be the answer to this question, and that's option B here, guys. So let's go ahead and wipe off all this, and then let's consider the next question. So guys, the next question here will be question number 6. It says, which of the following conditions will most enhance the spontaneity of a reaction? A, delta H is positive and less than C delta S. B, delta H is negative and delta S is 0. Delta H is positive and equal to T times delta S. And then delta H is negative and greater than T delta S. So guys, the answer to this question here will be option D. And we know why. This is because for this option D, at every situation, delta G is going to be negative. If these two are negative, it means that for all situations, delta G is going to be negative, because you have a negative value minus another negative value, and it will always give you a negative value all through. So guys, with this, we already know that option D is going to be the answer to this question for all values of delta H and delta T, having that they are both negative in this situation. So guys, that's the answer to this question, and that's option D here. So let's look at the next question. Question number 7. It says, all right, we have an equation of a reaction here, and the question here says delta G for the reaction above at 1300 Kelvin is negative 43 kilojoule. At this temperature, the reaction is A, exothermic, B, at equilibrium, C, not feasible, D, feasible. So guys, the reaction is feasible, and that's because delta G is negative. Actually, the reaction is spontaneous. So the reaction is an exothermic reaction, and it's also feasible. So the option that actually gives a better answer to this question is the option D, and that's feasible. And this is because it's already indicated here that the delta G for the reaction is negative. So if the Gibbs free energy is negative, it shows that the reaction will occur spontaneously, and hence it's feasible. So that's the answer to this question, and we're going to consider the last question here, and that's question number 8. It says the production of biogas from the fermentation of waste material is an example of A, combustion, B, refining, C, recycling, D, incineration. So guys, the answer to this question is option C here, and that's recycling. So the production of biogas from the fermentation of waste material is an example of recycling. So guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. Also, if you have specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So guys, don't forget to also share this video with your friends to enable us reach out to more people around. And we want to also use this medium to encourage you to join our YouTube channel community. Guys, that will be all for this video. Thank you once again for watching this video. See you on the next one.